Cool. Excellent. Thank you. So as Paul said, I'm going to be talking about vulnerability management today. My name is Feroz Salam. I work at Isovalent, which is a Cisco company. If you haven't heard of Isovalent, we work on eBPF-based software. If you work in the Kubernetes space, you might have heard of Cilium and Tetragon, and we were the creators of both these platforms. We ship a lot of containers. So we ship about 20 containers, and for various reasons, they have very different flavors, from Alpine to Distriless to Ubuntu. We ship pretty regularly as well. We have a monthly patch release cadence. So really a lot of my job is maintaining container security. And a big part of this is CVEs, as I'm sure a lot of you might have experienced. There are a lot of container vulnerability scanners at the moment, and they definitely give you a lot of results to deal with. So to get a sense of the scope of the problem, here are some figures. The number of CVEs assigned every year has risen significantly, about threefold over the last 10 years. Scanners tend to prioritize completeness over accuracy, so it's all about processing the largest number of programming languages and giving you the most complete set of results, rather than telling you accurately whether a set of results actually affects the software that is contained in a particular package. On the other side of the problem, you have customers who want zero CVEs for whatever reason. Either they're going to high security environments, or they've just got a very restrictive policy set by their security team. So I have examples of customers who have come to us and said, we want zero CVEs. We don't want to see any CVEs in this image. So how do you solve that problem? You can try these things. These are very reasonable things to do. So you make your container images as small as possible. You try distriless images. That really helps a lot. You automate your dependency updates. That helps too. So that means that when there's a new package update available, you take it as soon as it's possible. You put it through your CI. You see if you can bump that package, and then you ship those packages as frequently as you reasonably can. So your customers always have something that's fresh and contains as few CVEs as possible. And all of these things are really good things to do. We do them, and I would recommend that people should start there. However, all of this still leaves gaps. We still regularly see that, say, we release a package on the 15th of the month, by the 19th or the 20th, you've picked up more CVEs, and your customers might not even have put your new packages through their pipelines yet. So you're definitely going to get some questions regardless. You will always have third-party dependencies that are not under your control. So there will be binaries that you are pulling in from somewhere that you can't upgrade because the upstream maintainers haven't upgraded them themselves. And not everything is a trivial package bump, right? So there may be a new version of a package that is available, but you might have functionality reasons. You might not want to take it. You might have licensing reasons to not want to take it. So really, the goal of zero CVEs is very, very hard to achieve. So this leads to what I call the compliance doom loop. Somewhere a vulnerability scan is run, those results get compiled into a spreadsheet. The spreadsheet results get emailed to me. I feel very sad about it. But eventually I have to get over it, triage the vulnerabilities, and return the triage spreadsheet to where it came from, at which point I will almost certainly receive within the next couple of weeks a new spreadsheet with new CVEs. There has to be a better way of doing this, and that's what I'd like to talk about today. So I'm going to focus the talk around VEX documents, which are not a new technology. They've been around for a while. There are a few different formats of it, but the idea is always the same. It's a way of adding some extra information to the results output by container scanners to say, this package in this product is either affected or not affected for a particular CVE. As you can see here, it's super simple. This is the OpenVex JSON format. It's you specify the vulnerability, you specify the product, you specify whether you think it's affected or not, and why you think that way. So this is going to be the core of my talk, and I'd like to talk about some slightly more interesting things you can do with these documents once you have them. So the conventional VEX use cases are to sign your container images and push them to container registries. This is really useful to be able to tell the people who consume your container images that you have considered certain CVEs and you do or do not believe them to be affected. You can see that some major container scanners actually do support VEX file processing. So you can see the example output down there where you have the same VEX document I showed on the previous slide. And at the very final line of the output, you can see that one vulnerability has been ignored as a result of the package that, as a result of the JSON statement that we made in the previous slide. So super simple stuff. This was the classical use case as such of this type of document. But how do you go further with this? So one of the things we do at Isovalent is we integrate it with our CI/CD pipelines. So the main reason why I've seen vulnerability scanners not being used in CI/CD pipelines is because of the high number of false positives. Development teams do not want to deal with 25, 50, 75 false positives just for one CV that might be actually applicable. The integration of VEX documents mean that the scans are mostly green, about 85 to 90% of the time, which means that I can now hand this over to the development teams and say, you look after the VEX documents now, and it's not a huge burden on them to do this. So this also helps greatly with shifting left, and I'll talk about this a little bit more in the next slide. So moving the care of the VEX documents over to the development teams means that they also now are the ones looking at the new CVs and triaging them for applicability to the packages that they ship. So you see here that this is a colleague who I work with, and he has noticed that the vulnerability scan is failing. He has taken a look at the results of the vulnerability scan and has opened a pull request here to update the VEX document. He has triaged the CVE himself, and this is often the best way of doing things, right? Because the developers have the most context about the things that they are trying to ship. So he knows that it's a package that we do not use, so we're not affected by this. So we have added it to the exceptions list. We use code owners as well, so this has to go through the security team's approval before it gets merged. The document gets merged, and then the scan goes green again, and we have a documented reason as to why we whitelisted that within the code base. So it really helps with shifting left. This is something we use across most of the teams, and has been really successful in both lowering my workload and having more contextual information on why we have whitelisted certain things for various different packages. So once you have these documents as well, for the customers who don't want to run this as part of their pipeline, or who just don't know what VEX documents are or just can't consume them, you can also auto-generate documentation. So this is something that we do. We just take the VEX documents and turn that into Markdown and put that into a documentation portal. And that means that, for the customers who can't consume the VEX documents, you can point them at the documentation portal and say, rather than come to me with your spreadsheet, maybe go and look at the documentation portal and then come to me with the gap between what you've seen in your scan and what's in the documentation portal. Again, like a significant time saver for me and the team. So far I've talked mostly about how this would help me, but if you consume software as well, VEX documents that show that an image is affected, like this second example here, are extremely useful because they're extremely high signal. More than any container scanner, this is a really high signal that we have looked at this and we think it is affected and you need to do something about it. So I think building that into your release pipeline could give you really good contextual information that you probably won't get anywhere else. So I would like to end on a plea for the people who make software. Generate your own VEX documents. VEX still isn't as widely used as it should be. So there's a lot of open source tooling that could do with some improvement. And the community is really eager for contributions here. So go ahead and start using it. For the people who consume software, it would be really nice if the people who send me these spreadsheets could consider themselves whether certain CVEs are applicable or not before they send them my way. But in the event that that doesn't happen, you should also ask your vendors for VEX documents, instead of sending them spreadsheets. Ask the people who provide you with your scanning solutions. If it's not Trivia or Gripe, ask them to add VEX processing functionality. Prisma Cloud, for example, really widely used, doesn't have the VEX processing functionality and doesn't have it on their roadmap at the moment. So yeah, and finally, include VEX processing in your CI pipelines. Make sure that it is something that you are taking into account before you deploy into production, because it can really help the quality of your software. And that is it. Thank you very much. I'd be interested to take questions.
Are we doing questions? All right, okay. Are you happy to do a question?
Yeah.
You mentioned how after 4 days.
Yeah.
After 4 days, the new CVEs can come along. My software is perfect, but all my third-party libraries are terrible.
Yeah.
So tomorrow, do I have to rescan? And is it a daily cadence for ingesting new CVE metadata and applying it to this framework?
Yeah, we scan daily. Because of the overhead, we don't ask that people review the results daily, but we do scan daily. Yeah.
Oh, hello.
So in your example, you mentioned mod security, maybe for like SSL library, and you put it into VEX to ignore that because it's out of context. But what if the team starts using mod? That is a really good question. I mean, you have to have some sort of regular review process for the VEX documents as well. You can't. So currently, that is something that I go through manually from time to time and refresh whether these things actually apply. But there is no getting away from that process. Yeah.
Hi. Really like your talk. So obviously this is shifting left and, those comments in the VEX, format. How can you trust them? Because some of the comments seem quite just, it's not in the executable path.
Yeah.
How can we trust it? Especially, is there any control that you add to that developer assessment? Because sometimes it can be missed.
Yeah, absolutely. So we don't let developers merge those changes themselves. So there has to be an approval from someone within the security team before those changes can be merged.
1 minute.
So you were saying about getting the patches as quickly as possible and things like that. My thought was instantly about like the XZ backdoor, which happened a bit ago now. Like, how would you then mitigate against those sorts of threats with so like?
I don't think Vex solves that level of problem, to be quite honest with you. Yeah.
Last question, because we're on schedule now, but this one.
Does the with the tooling that reads the files or the allow for an exclusion or to time out? Because people might be tempted to leave it in there and say, "I'm not going to I can't be bothered to fix that."
Yeah.
So you could leave something vulnerable in there for months when they should deal with it.
That's a great question. I don't think the spec, as it's currently written, has a concept of an expiry date, and maybe it should actually. So yeah, that's definitely something to take to the working group. I think there is a working group that does do the improvements on this. So yeah, absolutely.
Right. Thank you very much indeed, Feroz.